This is example problem 7. And so our example problem 6, we resolved a force into U and V components. And the angles were relatively small to U and V. And it kind of led to an easier triangle. But some problems like this problem look more intimidating. They look harder. And so I've got a cable or a strut here that's 30 degrees from vertical. And I have a strut here that's 45 degrees from horizontal. And if I define this as a direction V, and I find this as the direction U, and I basically have a force vector which is equal to 200 Newton here. And when I resolve this 200 Newton force into two vectors that act in the U direction and the V direction. And this looks hard, but what you're going to do is you're going to draw a line parallel to the V, and you're going to draw a line along the U, and you could draw parallel to the U as well. But once you've drawn these parallel lines, then it's pretty clear that you've got a component in the U direction, which we'll call FU, plus a component in the V direction, which this guy plus this guy will give you the resultant force. So again, once you draw the parallel lines, it becomes clear what's going on. So this is basically just a triangle. And so we're going to, or a vector polygon that we're going to solve. So if you draw a larger picture of this guy's 200. This angle is 45. This guy's 30 degrees from vertical. So if you drop a construction line down here, this is 30 degrees. This is 45 degrees. So you pretty much know all these angles. So this is 200, this is 45. This angle here is 90 plus 30, which is 120. And then this guy here is 90 minus 45 minus 30, which is 90 minus 75, which is 15 degrees. So 15, 120, and 45. And those three should sum to 180, which they do. And so basically, I know all three angles in one side. So from that, I can use law of sines. So I go 200 over the sine of 15. That's equal to FU divided by the sine of 120. And that's equal to FV divided by the sine of 45. 200 over sine of 15 is 772.7. I get an FU is equal to 669.2. And I can get FV is 546.4. And then you're basically done. Those are the components of this guy. I guess if you had to write them as a vector, FU is at 45, so FU as a vector is equal to 669.2 at 45 degrees. And FV as a vector is equal to 540. And he acts this way, and so that angle is minus 90 plus 30, so that's minus 120. And those are newtons. So these two vectors are the components of this 200 that act along these struts. So again, we're just building your toolkit, we're building your skills. The question is, can I write X and Y scalar equations to solve this guy? And sure we can. Let's try that. So if if we sum the x components, the horizontal components, I basically have 200 is equal to FU cosine 45 minus FV sine 30. In the vertical direction of this component of this force is 0. That's equal to FU sine 45 minus FV cosine 30. This gives me two equations and two unknowns. So my two unknowns are FU and FV. My coefficient matrix is cosine 45, which is 0.707, minus sine 30, which is minus 0.5, sine 45, which is 0.707, and minus cosine 30, which is minus 0.866. And by the way, you should memorize cosine 45, sine 45, sine 30, cosine 30. Those are just numbers that you should have memorized. And my right-hand side is 200 and 0. So you put this into your calculator, and we'll use the simult function. So we're going to go on, catalog, simult, template, 2x2 template. And we're going to go 0.707 minus 0.5, 0.707, and then minus 0.866. It's our coefficient matrix. Then we're going to go comma, and then we're going to go to template, and we're looking for a 2-element vector. And then we're going to put in 200. And then 0. Enter. And we get 669.3 and 546.5, which are the same as we got there. And so this is just skills that you need to be able to do. It's not hard. You know how to use your calculator, powerful tool. And so these are all skills that you need to be great at statics. And that's the goal. The goal is to be great in statics.